Hey there, welcome to hour 6 of 100 hours of refactoring practice. Today we're going to be doing the Gilded Rose kata again. I'm going to go a bit quicker than I have in the first 5, just because I think we can get to a place where we can actually satisfy the requirements set out by the kind of the author of the kata. And I won't take a look at those quite yet. I'll wait until we get the refactoring done before taking a look at that. So to start, let's get our tests running here. And I want to run them with coverage because the coverage tool will actually help me with a refactoring that I'm going to be doing a little bit later. First thing we should do is get our tests passing. All right. IntelliJ likes to run all these slow code analysis, but I'm going to be going to say setup. Oh, and we got a GPG error. Let me just okay. I think we're off to the races here. We can start by changing this ugly thing into a require relative. And we want to use the non-monkey patched RSpec. And I want to separate this test into its phases. And I don't want the extraneous parentheses. And let's do dot first instead of the array access there. Okay, so that was just style fixes. Nothing meaningful there, but it's always nice to have nicer code. Let's take a look. We've got our files are in a weird spot, and there's kind of a convention for Ruby projects that we should probably be following. So let's do this. And let's create a spec directory as well. Okay, and actually our tests are going to fail just because there we go. So we're back to passing tests. Let's tell IntelliJ about these directories, test sources. I don't know that that makes too much of a difference, but it does let us bounce back and forth between the test and the production code fairly easily. Okay, so the first thing that we want to do is get some characterization tests. Well, not the first thing, but we now want to get some characterization tests around the existing behavior and update quality. The tool I've been using to do this in the previous practice hours is a tool called Approvals, and approval testing basically lets you generate a bunch of test outputs and save them to a file, and then approvals will verify that as you make changes that the outputs don't differ from that file. And it's a really excellent way to basically get all of the interesting outputs from a chunk of code, and then start to make changes to that, and then be confident that when you're refactoring, you're not changing any of the behavior. So what we need to do is add the approvals gem. And we can just say, try bundle install. And once we have this approvals tool, we can start to build up the approvals file with all of the interesting outputs. It takes a while to install because Nokogiri has to link against libxml. But in the meantime, maybe we can take a look at this this approvals tool. Yeah, so basically, approvals gives this verify block. And if there is a test failure, or if there's a difference between, I guess, the outputs that you've approved so far and the outputs that are generated by the test, you can run this approvals verify tool, and it'll bump open diff, a diff of the expected and actual values of the file. There's all this other fancy stuff for formatting because you need stable outputs between tests. And so sometimes you need to write custom formatters. But we probably won't have to care about this in the beginning. All right, I think using IntelliJ's built-in bundler is not going to serve us very well here. So we're going to run it from the command line. And actually, I do have to do some funky stuff with run configurations here. Serves me right for I actually have to do some okay. My development environment gets in the way again. Okay, so we have that. Let's just, yeah, they're the same. Just have to tell IntelliJ's test runner about this. And so now we can, okay, so we got our tests running, we have approvals installed. I think we're good to go. let's open production code side by side with the test code here. It's going to be important. Okay. I'm not actually sure why it would produce no. Oh, it might produce a no method error because first could be no. Okay, that's important. But we are in a test, so it is characterized. That's what we want to say, and we do have to add approvals to our spec so that we get this verify block and verify we want to verify all. It looks like what this code does is it takes an array of items, you call update quality on it, and then it mutates those items. And so the thing that we're going to be verifying is items. Items is going to be some array. We can just start with the original tests here, so that we can get a good. Actually, let's do this. I'm not sure what needs to be in the verify block, but it says all examples are filtered out, but that is baloney. Okay. Incompatible library version. Okay, let's try this again. Okay. If I bump over here and do a bundle pristine, and then bump over here. I have the most adverse development environment right now. When I get it to indexing so that I can run this Gilded row spec with coverage and see it pass and still get all failures. I wonder if I get these failures if I run it from the command line though. It doesn't fail. Well, I mean, it fails, but it doesn't fail. It doesn't error. So maybe there's something funky going on in IntelliJ. I had hoped we wouldn't have to spend so much time on this. All right, we're about 14 minutes in. Should say 45 minutes left. Just gotta wait for it to index here. Oh, this is such a huge problem because I've been using... Okay, let me blow away. Cat my bundle config. And me run bundle install again. Sometimes you win some, sometimes you lose some. Like this is a fairly basic mistake that I've had to deal with a number of times now. I use something that's a little esoteric in terms of development tooling. I use a package manager called Nix, and IntelliJ just doesn't support it very well. And I've had to learn a bunch of workarounds, but if I don't get them all just right, I end up in linking error hell, which is exactly the reason that, or exactly the problem I'm trying to solve with Nix. So okay, we're good now. Who knows why? Computers. Okay, so we can see we get this approval error. It says the approval file is not found. And we can, if we take a look at our diff, we can see that we have a received file. And approvals actually has this tool called verify. I mean, it'll do a diff between what has already been approved, which at this point is nothing, and what we just received in that test run. And we can see that it has this pretty much the output of the inspect method on the object, and this is the object we want. Actually, the array of objects we want, but the problem is this object ID is in there. So we need something more stable so that at every test run, if the values are the same, then there is no diff. And if we have this object ID in there, it's going to be the same, or it's going to be different every test run, and we're going to get errors every test run, but those will be false negatives. And so we need to do something with this items array to make it stable between test runs. And there is this 2s method that handily provides a stable a stable output for an item. And so now if we take a look at this again, we get this foo -1 0, which is going to be stable between test runs, so we can approve that. And this is all good stuff to commit. Let's take a look. Yeah, we can commit all that stuff, I think. Okay, and so now we need to expand this items array to contain all of the interesting inputs. It looks like if we take a look more closely at what this code does, we can see that name is referenced. So the item name, we're doing some switching logic based on that. We're doing some switching logic based on the quality, and we're doing some switching based on the sell-in. So we want all of the interesting names, qualities, and sell-ins to produce their own sets of input. So let me see if I can make clearer what I mean by that. So we're going to have a names array. And right now, it can just be that foo thing from the first test. We're going to have a selins array, and it can contain 0. We're going to have a qualities array, and it can contain 0 as well. And then what we're going to do is, if we can take the cross product of these, we can be reasonably confident that, it looks like it didn't commit successfully there. If we take the cross product of these 3 arrays, we can combine them. Yeah, if we take the cross product of these 3 arrays and create items out of them, then we can be reasonably confident that we've hit all of the interesting cases. And the goal of this in the end is to make sure that all of the code coverage, or all the lines and all of the branches, are covered in this code. Unfortunately, IntelliJ's code coverage tool doesn't show us branch coverage, but we can see here we've got green line coverage on these on these lines, and red on these. So we want no red when we're done here. So to take the cross product, we can use this handy method on array called product, and we take selins and qualities as the arguments to that, and we can map over these now. So we get a name, a selin, and a quality. And we just want to create an item for each of those, and then we can run our tests through. And this will pass because we just have the same we have the same inputs still for name, selin, and quality. All right, let's commit that, and we'll call it like input combinations, because that's what we're trying to get to. That commit succeeded. Okay, let's go through and start to pick apart what the interesting inputs would be. So we've got this age Bree is a good, interesting name. Backstage passes, also an interesting name. Sulfurous is also an interesting name. And let's see if there are other, so there are no other names, it looks like, that are of any interest. We do have interesting selins though. So this is a quality, we don't need to worry about that now. Quality selin less than 11. And it's usually a good idea to, we can probably do this all on the same line. Do either side of a number like this so that we know we can hit either side of the conditional. So we do 10, 11, 12, selin less than 6. We can do 5, 6, 7, and selin less than 0. We already have the 0. Whoa. But we should probably hit either side, like I was saying. And so now we can see like there is a lot less red in that gutter. And it looks like all the red has to do with these quality conditions, which is expected. We haven't covered ourselves for quality yet. So we've got quality at 0. We're going to do the -1, 0, 1 thing again. Let's just see what we do there. And that is surprising because, or it's actually surprising that we aren't hitting this, but I guess it doesn't matter right now. Let's do if quality is less than 50. So we'll do 49, 50, and 51. And now we have green everywhere. We have all the interesting inputs. And I think it's time to look at what that means in terms of the approvals file. So we end up with 215 different item combination or items that we give. Yeah, item combinations. So it's 215 combinations of name, sell-in, and quality. And this is enough to cover everything. And so now we can refactor with confidence. And let's just say full coverage. And we can, I just want to see this test pass first before moving forward. Okay, so it does pass. All right. Now that we have a good set of tests, I can close this window right out, and we can just focus on refactoring. The first thing I'm going to do is some stylistic stuff. I try to make it so that we access everything with the same access everything the same way. It just makes it easier to refactor and move things around. So I'm going to do the same thing here. Because we have the adder accessor. Okay. Uniform make variable access. Let's call it attribute. And the other thing we can do is take away this extra set of parentheses. I don't see anything else too interesting in terms of style. Okay. So now to the interesting part. Looks like update quality iterates through each item and then updates that item. It would be really nice if the code read that way. So let's extract the body of this into an update method. And we can see now items.each method update. Not like a huge fan of that. But let's make that the content of the update quality method. Now the update quality method reads like you'd hope it would. Maybe you'd rather the update method here be on item itself, but that's a bigger refactoring that we get to later. So we'll call this extract method. And now we can start dealing with the big, ugly, meaty part of this problem. The thing that we want to do is lift each of these name conditions out. And the way to do that is first we want to, so what we're going to want to have at the end of this is a big if statement based on name that contains just the logic for each of the items. And so the first thing we want to do is pull up a skeleton of this if statement. And we prefer to not change any behavior right now. So we will commit kind of a no behavior changing code, a change that doesn't introduce any behavior changes. And now that we have this if statement, what we want to be able to, or what we want to do is run all of this logic on either side of that statement. And the best way to do that is to, let me see if that got everything. It did not. Okay. So let's go and extract this into a temporary method. And so now we have this, we have this method that we can duplicate on either side of that condition. So we'll say extract method. Statement to conditions. And if we inline this, we get this inline refactoring not supported when return statement interrupts execution flow. This is because this big nested if statement, it can have multiple different return values. And so when we inline the method, what's happening here is IntelliJ is worried that that by inlining it, we're actually going to affect the return value of this upper level update method. And since we actually we know that applesauce is only mutating the item, so what we can do is just ensure that it has a stable return value, and that should appease the very sensitive IntelliJ's automated refactoring system. And that will make it so that this refactoring now works. And we can call this inline method. All right, and so why did we want to do that? Well, now that we've lifted the condition up, we can see which lines of code don't run when this condition is satisfied. And so we can see that with the code coverage markers in the gutter here. And the best thing that we can do with this is just delete this dead code. That too. And we can remove all this. And we can remove all of this. And you'll notice that we removed it on either side of the if-else there. And now that we've removed the dead code, we can start to simplify some of these conditions. Let's start from the top. But we see that there's an empty branch of this if-else statement. And that's because if item name equals HBRE, then this condition here is false. And if false and whatever else is always going to be false. And so this side always runs. So we can start to simplify the if statement. So that was an empty one. The same logic applies here. And if item name does not equal sulfurous, we know this is going to be, we know item name here equals hbree, so hbree doesn't equal sulfurous, so we know that this is if true, which is the same as just saying that. And we can continue down into this side of things. It looks like there's an empty else statement here. And if there's an empty else statement, we don't have to worry about the condition at the top. All right, so that is the first condition lifted out. We're just going to do the same kind of high-level refactoring but with a new condition. And so we'll extract this method. We'll call it applesauce again. Applesauce is a good name because it's too ridiculous to make a pass code review. We'll start with this backstage passes. Begin to delete this code again. Actually not super sure why we get the also with a rescue. Okay, we don't have to worry about that too much. So all this is dead. I feel like that was too big a change for this to possibly work. Okay, we have an error. Okay. Let me just back out until we're good again. So that was remove dead code. I'm just gonna make smaller changes. I shouldn't have ever had a test failure there. And delete that. And we can delete that. And delete that. I'm going to go back to the top and start to simplify this condition. So item name doesn't, that's true, and that's true. And so what we can do here is replace all of that, and we're good. So item name, if item name equals backstage passes is the same as the condition up here. So this is true always. And we can just put that in there, substitute that instead. If item name doesn't equal sulfurous, well, we know it equals backstage passes, so we know that this is true, and that this. That's very similar to the hbree case. And we have an empty consequent, so we can just replace it with the alternative. And we have an empty consequent here, or alternative here, and so we can just replace it with the consequent. And we have an empty alternative here, so we can replace it. Yeah, that was right. Oh. Yeah. And so there we go. We've now simplified, or we've got all the backstage pass logic lifted out, and we just need to do the last bit here, which is, oh, I don't know what happened there. And we need to lift out the sulfurous case. Let's do this. And inline and remove the method. And see that this doesn't run, and so its surrounding if statement doesn't run, so that's deleted, and then we end up with like an empty if statement here. This is empty, all of this is empty, and so sulfurous doesn't have much logic in it. Okay, now we have the kind of normal item logic remaining here. And we know that we've already extracted or lifted that sulfurous condition out, so we know that the item name doesn't equal sulfurous. So this is the same as true, this is the same as true, and this is the same as true. And so now we have got the essential item update logic for each item type. And we can say, so that was simplifying the if statements. Okay, so we're now in a good spot where we can start extracting the update logic into preferably its own like updater method. What we're gonna, I wonder how we're gonna make that happen. Well, the best way to probably get started is to introduce method objects. So let's say we have this set of updater objects. And each of them is going to take an item, because that's what each of the method bodies are operating on, is that item. And let's have them have an update method, and we will just duplicate the logic there. And then we can replace this. So we can say hbreeupdater.new item.update. We have an error here. Oh. All right. And so we've now got a HTTP updater. All of that logic has been extracted into its own method object. And we're going to do the same thing now for backstage passes, and then we'll do it for sulfurous and normal items. And let's do backstage pass updater item dot update. Shit. Yeah. We're even going to do it for sulfurous because the real value here is that is the polymorphism that we get from that update method. What it's going to let us do is kind of abstract away the details of updating the item from the Gilded Rose class. We can just say that that's the only logic that's going to live in the updated item. So introduce the method object. Do not know where my cursor went. And then we're going to actually use it here. And finally, we're going to have a normal item, normal updater. And we will copy this here. Wasn't quite extract, but let it happen. And so now we've made the oh, I probably forgot the constructor. The snippets for IntelliJ should have something that creates that kind of object for me. This sort of value object. But now we can see in each condition, the body of each condition looks nearly identical. And that's going to unlock the ability for us to make or to add new items very easily, probably with just a couple lines of change. So, which is what we're trying to go for with the requirements. So let's say extract method object again, because that's what we did. One final thing is whenever you see like the well, actually, let's do this. Okay, I think it's, say extract or introduce variable. That's what we want on that expression. We want to call it updater. We want to do that same refactoring on each of these, and the reason for that is then we can move the actual logic out, and we can begin to see that this is looking a lot like a hash map. And there's and so we're getting ourselves closer and closer to the hash map. Let's slide out slide statement from conditions. Okay. And so let's do the work to make this this hash map a little more explicit. So we'll call it names to updaters, names to updaters, or names to updaters is equal to, and we'll say aged. I can probably turn this into a macro here. So if I and actually we can just move that into there. And so now we can create new updaters and add them to this hash map with only the amount of code it takes to create the new updater and one line, which is the mapping of the name to the updater itself. And this no longer seems like it belongs to the Gilded Rose class, but instead it smells a lot like a factory constructor. And the way that you usually want to build those in Ruby, there's like a little bit of a pattern here. You would have a namespace, or let's make it an explicit namespace module updater, and you stick all your classes into that. you usually have a method that's called for or something that indicates that it's sort of factory method, and we can do oh, did I screw it up? What we want to have this say is updater for item dot update, and we will push this into that. And let's see if we can do, I don't know if we can extract a constant here. If we can, it would be very nice. Introduce constant. Not very good at hitting enter. Name to dater. And we can just do the refactor. Okay. Oh, let me bump back to the test here. Run it with coverage. Okay, an error occurred. Uninitialized constant aged pre-updater. Okay, I think that could just be some constant resolution problem with that. I just don't understand constant resolution with Ruby. So we could do that there. Probably get a testing, okay. So extract factory constructor. And then this line, or this method's no longer doing much work. And so we can just inline it. And I think our gilded rows will be better for it. So items at each updated for item update. And we have this updater module, which I think we can now move. Let's see. That worked. That's pretty cool. Let's see if we can move the updater age pre-updater. So yeah, so this is why I use IntelliJ. And that is it for this this practice session. Unfortunately, I didn't get to the point where I could add a new updater, but that was largely because my project setup was really janky. I think we'll definitely be able to get to that the next time. What is nice is we have started to kind of peel out the different parts of the project, and I think we're going to end up with something pretty legible by the end of the real refactoring next time. Like if we actually take a jump here to where this is defined, this require relative is kind of gross, but we can fix that up later. But the really interesting thing is that we're peeling out each of these updaters into their own files, and so we're ending up with a pretty nice project structure. I've never seen that kind of package deal before. I wonder if I can I will take a look at this later. But that's been hour 6. Thanks very much for watching if you did. And I'll see you next time.